you.
Dear Heavenly Father, we're grateful for this day. We're grateful for everything that we're able to get done today. We're grateful for this time that we have to meet together as a group, and I ask you to bless the other members of our group, that they'll be able to join us on here soon, or that they'll be able to understand what we are learning. We love you, Father, and we just ask for thy blessing that we'll be able to work smoothly tonight, and that all will go well. We say these things in the name of Jesus Christ. Amen.
Thank you.
Alrighty. So did you have any questions on the homework?
No, I went through it and I'm a little fuzzy, but I think I've got it, because I think, working with the applet, if I can get it to work right, I think it'll be fine. I think that's what we're going to be using tonight. So
yeah, I feel like for the most part, the only thing that it added on chapter 6 was just putting what we learned in chapter 6 into an equation, basically.
Yeah, exactly.
So, all right, well, let's start the quiz.
Alrighty. Okay, I'll start. Use the normal probability applet to find the combined area under the standard normal curve that is to the right of z equals 1.358 and to the left of z equals negative 1.358. Round your answer to 3 decimal places. Example. So there's your example. Enter 0.989 in the box, if that's what the answer is. So if we put these in the applet, we go to the right, it's 0.0872.
Mm-hmm.
So it says go to normal curve that's to the right. Okay. And to the left. So it would be the same to the right as it would be to the left. They're the same number. We combine the two, it's 0.1745. I've got to see if I can remember how to do this one. What's it asking us to do?
Okay.
So if we put the 1.358 in the z-score and highlight them both, is that what they're asking? Is for that answer up on top? 0.1745?
Just a sec.
Yeah. Oh.
Why am I being confused right now? I just did this and understood it.
Yeah. Probably because there was one thing in there that said, well, you do this and you do this to get this.
Okay, so we were just adding. Wait, so we're just adding the two areas together.
Yeah, that's what I would think. Is if you highlight the left of it and highlight the right of it, you're going to get the area.
0.1745, which would be 0.175.
Yeah.
So that's all we do then, right?
I think that's all we're doing. It seems like it should be more complicated, and I think that's what's confusing.
Yeah. Okay. Well, I think that's it.
0.175. Okay.
All right. Question 4. Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? The distribution of individual observations, the distribution of the sample means, this cannot be determined. It'll be the distribution of sample means.
I would say it can be determined, so yeah, sample means.
So, sorry, you said the second one?
Yeah, that's true. Yeah, because if it's large, it's going to be closer.
Yeah, I think that's the one. I think that's what we were basically just talking about from the other quiz.
Exactly. Yeah. So the distribution of the sample means.
Yep, it'll be smaller.
I don't think we really went into individual observations too much.
Mm-hmm.
Which of the following results implies that the spread in X decreases as the sample size increases? If I remember right, I want to say the law of large numbers, but let me go back and look at the law of large numbers again. The law of larger numbers states that as the sample size gets larger, the sample means will get closer to the population means.
Is that what it's saying?
That's what it says for the law of large numbers, but I don't think that's what this is saying. Which of the following results implies that the spread in X decreases as the sample size? Well, okay,
So
so
that's the distribution of sample means.
yeah.
So as the distribution of sample means decreases
Increase.
as the sample size increases.
Yeah. So as the sample size is increased, then the standard deviation of sample means will decrease. And that means the fraction will get smaller. That's the law of large numbers. I think that's what that is. I could be wrong, but I think that's what it is.
I can agree with that.
In chapter 5, I think it was covered.
Yeah, it's just using different language, so.
Yeah. If it increases, it's going to come closer together, so it's going to decrease.
Yeah, and that makes sense. The more sample you have, the closer it's going to get to the population. Okay, cool.
Okay.
Wonderful. All right, so then next is use the following information to answer the next 4 questions. Scores on the quantitative portion of the GRE are approximately normally distributed with a mean of 150.8 and a standard deviation of 8.8.
Okay.
Dinah or something like that earns a score of 160 on the quantitative portion of the GRE. What is the z-score corresponding to Diana's score?
Hey there, guys. Sorry I'm late.
Hi, Zach.
You're good.
Okay, so if wouldn't it be, is it 150.8 minus 160, or is it the other way around?
It's the other way around.
I always do that backwards. I don't know why. I got to get that straight. Hi, Zach.
Yeah, hey there. Isn't it
here?
the variable that comes first?
Yeah, the variable and then the regular.
Okay, so we subtract that first, and then we divide the 8.8
Yep.
squared.
Which is the standard deviation.
Yeah.
You don't square it unless there's a
1 by it. Okay.
you have to. The only time you square something is when there's a number, like they had 5 samples.
Oh, okay. By the way, Zach, we're on number 6 here. We'll catch you up here.
Okay.
6, okay.
Sorry, I'm not going to normally be this late, but I work out in the Idaho desert. Well, I guess it's more of a tundra instead of a desert, and they're repaving all the roads before winter hits.
Oh.
And so it's just one of those things where they closed it down to 1 lane, and you had to wait for a pilot car, and now I'm stuck on the bus. So.
Okay, so I got a negative 1.045. Did anybody else get that, or is that just me?
I didn't get a negative.
Negative is positive. 1.045.
Yep, that's what I got.
I got to remember, negative is positive. 1.045. Okay. That was number 6, Zach.
Okay, I am opening up iLearn right now as we speak.
Okay, we will wait.
I appreciate it. Sorry, guys, almost there.
No
You're
problem.
good.
Okay, what did we get for number 3?
Let's go back up here.
So that one you just punch in the z-score into the normal probability app, and we just highlighted basically the two end ones, which
Okay.
come out to 0.175.
Awesome. Okay. And for which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population?
Mm-hmm.
Let's see.
Since we really haven't done individual observations, we
Yeah.
chose sample means.
Yeah.
Seemed logical, but then again,
Well, we'll see.
all right.
Okay, and then which of the following results implies that the spread decreases as a sample size increases? And I want to call that, I know I'm going to get it backwards, but isn't it the law of large numbers?
It is.
Yep, that's what we got.
That's right.
Okay, awesome.
Awesome.
And then you said we were on 6?
We were on 6, and that's where we got the 1.045.
Okay,
We subtract that's when I always reverse them.
gotcha.
Okay. So now we're on number 7.
Okay.
What is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE? Round your answer to 3 decimal places. So if we put that 1.045 to the right in the z-score, is that how we do that?
Yep, I believe so.
So we get a 0.087 because it's at 872. It says round it to 3.
Sorry, say that again.
0.087. So the answer would be 0.087.
How are you getting that?
Well, that's just, oh, you know what? My thing went back to something else. Hang on. But that does not help, does it?
I'm
Okay,
sorry, I'm pulling up the applet.
0.148. You like that one better?
Yes, I do.
Okay. It was that one we were talking about earlier, and it was
Okay.
That's yeah. Okay.
That doesn't sound quite right.
Yeah.
All right, great. Well, yeah, then we got the same answer.
Wrong. Okay, so we'll have to clear our fields before we do it again. Okay, Zach, your turn.
Okay, sorry, what was that last one? I was pulling up the applet.
0.148.
Okay, thank you. All right, a random sample of 5 students was selected to take the GRE. Their scores are 160, 175, 163, 149, 153. And the question is, what is the z-score corresponding to the sample mean of these student scores? Round your answer to 3 decimal places.
So we need to find their mean.
Yeah. So you're working on your
Which I just did real quick. It's 160 again.
Yeah.
Okay, so that's the sample mean is 160.
And this is the one where we use the square root of 5 in the equation.
5. Okay.
So it's equal to 160 minus 150.8 divided by 8.8 divided by the square root of 5.
5. Yes.
which I got 2.338.
It was 160 minus what?
150.8.
Okay.
And then divided by, I don't know if you guys are doing this in Excel or not, but then
I'm punching it all in my.
I'm doing it manually on a calculator. 2.337. Am I even close?
yeah, I got 2.338.
Okay.
And then it was divided by 5?
The square root of 5.
By the square root of 5.
Yeah. So if I put mine out one more decimal point, it's 2.3377. So I think that's why it's rounded up to 2.338.
Okay. Yeah, I'm good too.
All right.
So
Sweet.
we're going with, wait a minute, we're going with 2.338, right?
I think so.
Okay.
Yes, this.
Rounding up. All right. Okay.
Is it my turn again?
I think it's my turn. What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem?
Is this the one where we use the 68, 95, 97, or 99.7 rule?
I don't know. Can we just punch in our z-score into the applet and?
Yeah, that's what I was thinking.
Yeah, you know what? Okay. I think I was thinking of something else here anyway.
Okay, so above.
So I'm getting 0.0097.
That's what I'm getting.
So we would
Me
round
too.
that up to 0.010, wouldn't you?
This is the part I never know about. It's like, do I round? Don't I round up? But you know what?
Well, it says round to 4 decimal points on this one.
0097.
Okay.
Yeah, so never mind. I just need to read directions.
I always have that problem. So 0.0097.
Yep.
Okay. All right. Okay. Suppose the mean GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. It is well known that this distribution is left skewed. A random sample of 81 students will be drawn. What is the shape of the sampling distribution of the random variable X, which represents the sample mean of the 81 students who are selected? Well, wouldn't it be approximately normal? It's a large sampling, isn't it?
Yep.
It is.
So.
Yay, one I could answer. I don't know why I'm so confused tonight. I guess because I haven't eaten today. So there we go.
That'll do it.
Yeah, really well.
Okay.
All right, are we back to me?
Back to you.
Okay, 11. What is the mean of the distribution of the sample means for all possible samples of size 81 that could be drawn from the parent solution or from the parent population? And I have to scroll back up, sorry.
There we go.
Isn't it just the 3.5? Isn't the mean of the sample the same as mean of the group?
Exactly.
That's exactly what it is.
That's why it only wants 1 decimal point.
Yeah. Yes, it gives us clues, doesn't it?
Yeah. All right, what is the standard deviation of the distribution of sample means for all possible sample of size 81 that could be drawn from the parent population?
Isn't that the exact same question?
Yeah, almost.
The first one was the means. Now it's the standard deviation. Okay, sorry.
Now,
Yeah, what's the standard deviation?
So that's wouldn't that just be the 0.7 divided by the square root of 81?
yes, that's
Yep.
exactly what that would be.
Oh my. All right. I got 0.078.
Yep.
Right.
Yep.
Yep, me too.
Okay. Awesome.
I didn't read the last one, right?
Old time
Did I read
calculator here. A little slow. Okay. My turn again? Let's see. Number 13. What is the probability that the mean GPA for 81 random selected BYU Idaho students will be less than 3.3? Round your answer to 3 decimal places. Less than 3.3.
All right. So first we need to get the z-score, which
Yeah.
I got was negative 2.571.
You have this in your Excel sheet again?
Yeah.
Make me one of those. Huh? Have you send me your Excel sheet. So that's 0.0051.
Yes. That's what I got.
Yes, me too.
So just 0.005 for that answer.
And it wants it 3 decimal places.
Yep.
So 0.005.
Yep.
Okay. Almost done, guys.
Alrighty. 14. What is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be greater than 3.3?
.995.
Yeah, because you got to round it up.
Yep.
Oh, okay.
Yeah, so you take everything, yeah.
Basically what's left over from the last answer.
Right.
All right. Oh man, this is a long one. The United States Coast Guard assumes that the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but was raised after a tragic boating accident. The standard deviation of passenger weight is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean, than was observed in this sample. Note, as extreme or more extreme means that we are not only interested in values that are lower than the ones we observed, but also values that are far away from the mean as ours in a positive direction.
Okay.
I don't get the note. Is that supposed to change what we're doing?
You know, I'm having a hard time with this one. What's the deal?
Me too. Let's see if. How did you guys set it up? I did the 177.6 minus the 185. Did you guys get that so far?
That's
Yep.
what I did.
And then over, was it the 26.7?
I did 26.7 divided by the square root of 48.
Yeah, that's what I did too. And so, let me see what
So it made my z-score like negative 1.920.
that's exactly what I got. Negative 1.92018. Yeah.
And so if it, and then basically, and then I just highlighted on the normal probability applet what was more and what was less from those two lines.
Okay.
So you got the
I mean, it seems like it's giving us. Yeah, so I got 0.0549 is what I got.
0.49. Okay, mine's rounding up again, and it's really making me crazy.
But it seems to give us like more information. It's talking about extreme and more extreme. The note, it's just making me question myself. Like, is there something else I'm supposed to be doing here?
Yeah, I I don't know either.
I think it's not only the lower ones, but the ones that are way lower. But I don't know.
What did you get then? If you did both of them, was it the one what I said? I just lost everything.
If I highlighted both sides, I got 0.0549, which is 4 decimal points. So that's good because that's what I wanted. But
Yeah. Well,
I don't know if that's.
I don't know.
It's wanting more. I don't know what else to do though. I don't know of any other equations to use to get the super far stuff.
Right. I I have no idea either.
Well, should we check it out and see? Should we submit it? See what happens?
Oh no, it is 3 decimal points. Oh, I'm such a dummy.
Okay, so it's 0.55.
Yes. All right. Well, let's put 0.055 and see what happens.
We're saying 0.055?
Yeah.
I think so. Did you have something else?
No. Okay. I just sometimes I get funny about entering these numbers in.
All right, well, let's see what happens.
All right, submitting.
0.055. That's what we got, right?
Yep.
Okay.
Hey, 100%.
Now, if we all actually
The
answered.
question was just lengthy to confuse us. That's nice.
Yeah, makes us think that we're doing it wrong. Enough information that we're like,
All right.
cool beans,
So
guys.
I don't know if you guys. Okay, so you know how I have been having issues with Excel and it's slowing down my computer? I don't know if you guys know, but there is this app if you have a smartphone called photomath.com. And they call it that because you can take an equation and take a picture of it and it'll automatically solve it. But more than that, you can, it has this like little calculator function on it. And like all of these equations, like when you take your sample and subtract your mean and then divide that by your standard deviation, which is also divided by your square root of whatever you're doing. You can enter all that in this calculator, and it comes out, and it'll break down step by step how it gets the answer that it gives you.
I'm gonna
Wow,
have to
pretty
read
cool.
that. Okay,
So
Photo Math.
yeah, Photomath. It's an app for your smartphone.
Okay, works on it.
So yeah, it's pretty awesome because if you're not actually getting it, you
Yeah,
can go through it and just read step by step the directions it took to solve it.
I need to
So
look at that one, I think.
yeah, it's awesome. So it's saving my butt.
Okay, I'm gonna have to download that on my phone. It works for iPhones and Androids.
I assume so. Yeah, I have an iPhone, so it's I just go to the App Store and grab it.
I'm old school, so I will try it on the Android.
Sounds
I'm
good.
resisting those iPhones, I'm telling you guys. So,
Right.
have a good night, guys. Thanks for the help.
Yeah,
Thank you.
Night.